Cool. So we've got a lot to cover today. So we'll kind of just dive in. First off, we're very excited to announce it's been a long time in the works, and I'm excited to announce that RV Solar Connections is now officially Trek Systems. And next week, we'll be launching our new website. We'll make it easy. So if you go to RV Solar, it will redirect you to Trek. And so it should be a fairly, seamless transition. Much of the layout and the functionality of the site will remain the same. So it should be good. In the last webinar, many of you asked to learn about secondary alternators and how to properly install an Arco Zeus regulator, the ins and outs of what that looks like. So that's what today's presentation is all about. This will be available on YouTube in about a week, and will include timestamps so you can jump to sections you might want to rewatch. Yeah, let's jump in. So first, some quick introductions. My name's Kaza Gomis, founder of Trek Systems. Today we've also got Dan Birkbeck and Peter Roach. And from Arco Marine, we've got Ben Stoddard, CEO, and Nick Ernst. He's the tech guru, and I'm sure he'll have some things to add and some notes to share with us as we get through this. So really excited to have them here today. Towards the end of the presentation, not quite the end, but the second half really, we'll hand it over to Arco, and they'll talk about some of their high output alternators and sort of what sets them apart. But first, let's look real quick at the agenda. First, we're going to talk what's new from Victron. For those of you who joined us for our last webinar, that was the primary focus of it really, were updates from Victron. And we're going to include a section about updates from Victron on every webinar. We'll typically highlight it at the beginning, just let you know anything new that's happening. I do have news that I received yesterday that is in regards to the tariffs. There is going to be a 30% increase on all products manufactured out of China for Victron. The good news is that many products from Victron are manufactured out of Malaysia and India. The primary products that are going to be affected in this 30% increase, which is effective immediately, are going to be the Victron lithium batteries, and then some fuses, some cables, a number of other, not so common products. The primary products will not be affected are solar charge controllers, the Multi-Plus and the Quattro, inverter chargers, and the DC to DC smart chargers. We're going to send out a newsletter today, probably shortly after the webinar here, and send you a list of all the products that are affected. So you can keep an eye out for that. But yeah, let's pass it over to Dan and hear more about the positive news from Victron.
All right, thank you, Kaza. So like Kaza said, building on our previous webinar, there's been a few more updates since then. One of the main ones is the VRM smartwatch app. For those of you who use a smartwatch for VRM monitoring, it's been some new features that have been integrated. Adding VRM directly to your smartwatch face is now possible. So now you can have tank level monitoring at a glance on your wrist. You can control relays from your smartwatch to turn loads off and on or whatever you're using that for. Also controlling a generator, turning that off and on as well. So it's a nice little feature. Most recently, this Victron Connect, new version of that just came out on, I think, Monday. And a new cool feature that they are working on, it'll be coming here in the coming days is it's called VRM Deep Links. So now you'll be able to access VRM settings. I'm sorry, Victron Connect settings within VRM without having to leave the VRM app. So now within the device list of VRM, you'll be able to access those settings quickly. And in addition, VRM has added a new fleet dashboard for anyone managing fleets of more than 10 installations. New VRM dashboard for fleets. It'll give you kind of a clear overview of all sites and show current alarms and any potential issues you may need to troubleshoot. And last but not least, a couple of the Orion DC to DC chargers, the new options available from Victron. One is the 12 to 48 volt charger. Now we've got a good 12 to 48 volt charging option from Victron that is now available. And then the new Orion XS 1400, that is up for pre-order now. Expecting that to be available end of this month, early May. We'll drop a link in the chat for anyone who might be interested in that. And that's about it. So I'll pass it back to Kaza here to get more into our main topic today.
Thank you, Dan. Okay, so before we dive in here, has anyone here with us today installed a secondary alternator system before? If yes, please drop your company name and city state in the chat. It can be tricky to find competent service providers for these types of projects, so we're looking for professionals that we can recommend. So why would you choose a secondary alternator? Some of the big reasons why, well, number one, you have a large battery bank. If you've got a pretty large battery bank, and then especially if you have a large battery bank with limited space for solar or to have an onboard generator, that's where these come in most handy. Things that you'll benefit from with a secondary alternator, well, fast charging, and we'll do some comparisons here in a bit between secondary alternators versus DC to DC chargers to see exactly what that comparison looks like. The ability to charge regardless of what the weather looks like, whether you have a cloudy day or a series of cloudy days, a storm, whatever it might be. If the vehicle's running, whether it's idle or at cruising speeds, you'll still be able to get a really significant amount of power to charge your battery bank. Mission critical applications where you've got to know that you have that power available and the ability to charge those large battery banks. Some of the most common applications that we see these in, of course, camper vans, large motorhomes, expedition vehicles, specialty vehicles like mobile medical or emergency response, security, things like that. Also very popular in the marine world with yachts and even smaller boats. The secondary alternators have actually been popular in that world for quite a bit longer than they have in the RV space. So I'll pass it over to Peter, and he can share a bit more about what differentiates secondary alternators, DC to DC chargers, and how to choose between the two. Peter?
All right. Thanks, Kaza. So yeah, let's in this context, we're talking about charging Victron lithium systems with DC to DC chargers and second alternators. So let's compare second alternators and DC to DC chargers. These are the two common approaches to charging from the vehicle. So both share a lot in common when used within Victron systems. And when talking about the Orion XS and the Zeus regulator, we see that both communicate their data to the Servo GX. Both of them can be controlled by DVCC. They are both configurable and programmable via Bluetooth apps, and both display their data and history in VRM, which, as a lot of us know, is very convenient when we're troubleshooting these systems. We're going to kind of compare some of these differences here. So we have dedicated secondary alternators, we have an alternator that's dedicated to charging the house battery, whereas with a DC to DC charger, we're using the primary alternator on the vehicle. And a secondary alternator is going to have a much higher output, much higher power output than we see with a DC to DC charger. And as Kaza mentioned previously, large battery banks really benefit from higher power output charge sources. So second alternators, ideal for large battery banks, DC to DC chargers, ideal for smaller battery banks. As far as the install procedure on these two units, I think a lot of us are very familiar with installing the DC to DC chargers, like the Orion XS. And compared to the secondary alternator install, it's very simple. The secondary alternator install is an advanced install that throughout this presentation, we're going to kind of show you how to kind of break it up into chunks and show you how it is a manageable install for you and your team. And then lastly, the communication protocol to the servo and how the Zeus regulator communicates its data to the servo, and then the DC to DC charger. The Orion uses a VE direct communication cable that goes directly to the servo, and the Zeus uses CAN bus communication and NEMA 2000 communication. All right. So just right here, here we have stats for an Orion XS 1250, and then we have some stats over here for an Arco 48 volt alternator. This thing is a beast. For charging a 48 volt system, this provides a whopping 7,300 watts. That's unparalleled for charging a large 48 volt battery bank. So that can be very helpful in a lot of the situations that Kaza had previously outlined when being off grid.
Well, yeah, it's huge, and not to take away from the Orion XS, it has its place, and you can stack those in parallel, and it's the install is a bit simpler, a bit quicker, things like that. But when you have these specific applications that we talked about, whether it's a camper van with limited space for solar and they're wanting to run an air conditioner, or it's a giant motorhome and they have a massive 30, 40, 50, 60 kilowatt hour battery bank, just don't have the space to accommodate the solar, that's when the secondary alternator really becomes a viable and maybe the preferred option. Yeah, real quick, just to double tap these stats. And this isn't max, this is sustained cruising output and sustained idle output. We do have spec sheets and charts that show what RPMs you need to be at in order to achieve this output. So we can certainly talk about that. And I think Ben and Nick might share a little more about those specifics here in a bit. But yeah, just wanted to weigh in a little bit on that.
Right, I do see Jeff asked in the chat, just can it step down to 12 or 24 volt banks? So when you're using a second alternator, you're going to pair the voltage of the second alternator to the voltage of your battery bank. So this alternator on the left here would be for the case of charging a 48 volt battery bank. This alternator outputs 48 volt. So for a 12 volt or a 24 volt battery bank, we're going to pair those with a 12 volt alternator or a 24 volt alternator on that.
Nice. And yeah, definitely please engage in the chat and throw questions in there. We'll save all of those for the end. So feel free to put questions in as they come up, but we'll have a whole section at the end dedicated to Q&A.
All right. So the big difference here that we're demonstrating is that, DC to DC chargers, we're using that primary alternator that's installed in the vehicle, which is also providing power for the vehicle starter battery and the electrical system. With a secondary alternator, we're generating an entirely new power stream. It's like taking the shore power with you, but you have it on the road. All right.
Yeah. And yeah, just real quick, wanted to touch on this as well. When we talk about, okay, choosing between a DC to DC charger and a secondary alternator, one of the big things to think about is the DC to DC charger is going to pull off the primary alternator. Now, you might have dual alternators from the factory, and if that's the case, then the DC to DC will use power being produced by both of those from the factory. But the difference is with a secondary alternator that's dedicated to charging your lithium house bank, you can get a lot more out of it. Getting a dual alternator from the factory, yeah, there's some pros with that, and you can again stack multiple DC to DC chargers in parallel. But you won't see the type of output capabilities that you'll find using a secondary alternator dedicated to charging a lithium battery bank. The other thing, if you don't have, say, dual factory alternators, say you just have a single alternator, well, the DC to DC charger is going to be adding some extra stress to that alternator. So if you size it appropriately, there shouldn't be a big deal. It shouldn't significantly impact your primary alternator to the point where it fails much sooner than, say, it would have anyways. But anytime we stress a component more, it's just going to fail sooner. It's being worked harder. And so when we're using DC to DC chargers, we got to be really careful not to stack too many of those in parallel, relying solely on the primary alternator. Because if you do that, then it might work for a little while, but you're really going to increase your risk on getting stranded somewhere because you overtaxed your primary alternator, and now it's failed prematurely.
On that note, if you are, upfitting a van, I know that Mercedes has about an 80 amp current limit if you are pulling off of the stock alternator in the vehicle. So consult the manufacturer when you're adding DC to DC charging like that.
Awesome. Thank you, Peter. And now we'll jump into our experience with Arco Zeus and secondary alternators in general, whether it's Wakespeed or Balmar regulators being used. We've been working with these for several years now, and we're seeing more demand than ever for these types of systems. We do strongly encourage that these installs be done by professionals. There's a lot involved, and if you don't know what you're doing, you could easily destroy an alternator or worse. That said, we expect the demand for secondary alternators to continue rising. So if you're a professional on the fence about offering these, I can say that we work with a number of outfits currently offering secondary alternator upfits, installing them with good success. And having this capability will absolutely give you an edge in the market. And we're here to help so that you don't have to learn some of these lessons the hard way. Later, we'll talk about our tech guides and the SOP documentation that we've been developing for easier installation. But for now, I'd like to introduce another industry expert with vast experience installing secondary alternators across a wide range of applications. I had the opportunity to work with Andre from the Yacht Rigger on the advisory board during the development of the Arco Zeus. And yeah, this man runs an incredible company out of St. Pete, Florida. Andre, yeah, thank you. Thank you for being here today. And can you share a little more about your company and your experience with secondary alternators?
Sure. Like you said, I own and operate the Yacht Rigger out of St. Petersburg, Florida. I have two other business partners, Brian Ford and Stephen Lloyd. We all come to the business with different experiences. Steve is a rigger, so we sell masts, rigging, running rigging, sails, etc. Brian is a fabricator, so stainless or aluminum. We can custom fabricate any part that's needed on a vessel. And then where I come in is the electrical side of things. So we offer what our customers like to refer us to as the one-stop shop. which is very nice. The only thing we really don't do is bottom work and engines. So the Arco Zeus has been a really nice addition to some of our offerings. Our clients really enjoy it.
Awesome. And with Arco Zeus or secondary alternators in general, are there any major challenges that new installers should look out for?
There are, of course. Now, Arco has done a really good job in making sure that their integration with Victron and the installation of the Arco Zeus itself is fairly streamlined, and the problems that we encounter with that part of the installation is fewer and far between. Where we find, and this might just be something associated with the marine industry, I'm not sure how prevalent this is in the RV side of things, but when you're replacing an alternator, it's not always a direct replacement. Oftentimes we have to shim it forward or aft or customize a bracket to hold it on the engine. And belt alignment is very critical to make sure that you can pull all of that power from the engine. So the biggest challenge, in my opinion, especially in a marine side, is the alternator installation. Now, that doesn't mean that there isn't a direct replacement style installation. It does happen fairly frequently, but don't be surprised if there is some alignment to be done while installing an alternator. Has been our biggest challenge.
Yeah, that's a great insight. And in the RV and camper van world, luckily we've got a number of kits where it's still involved, don't get me wrong, but there's documentation and there are kits, bracket kits and things that allow you to more or less swap out what you need to in order to fit the alternator. In many cases, there aren't custom shims or things like that you need. There are, and I'm speaking primarily about the most common use cases, right? Those of on the Mercedes Sprinter platform or the Ford Transit or the Dodge ProMaster. There are a number of bracket kits for many applications outside of those that are most common, which again usually don't require any kind of advanced customization with shims and things of that nature. But yeah,
Yes.
definitely in terms of installing the alternator, that's probably the crux of all of it, really.
Sure. Yeah, you're lucky in the RV industry that you don't have to deal with that as much. I guess there's a lot more of the same engine out there that is being worked on as opposed to the marine world, I suppose. But that's good.
Yeah, and could you share a favorite or maybe just a unique project that you've worked on that utilized an Arco Zeus?
Sure. Well, there's a lot of our larger and higher end projects that do. Our specialty is mostly on catamarans, so there would be two Arco Zeus, two high output alternators, and out of all of the work that we do, usually the energy system is the one that gets a lot of feedback, and it's usually, our customers will come back to us and say, "Oh, look at my solar array and how much power it's putting out," or "Look at how much power I'm putting in my battery bank from my alternators." And so I would say the power production from both solar and the Arco Zeus are the two number one things out of the vast majority and diversity of things that we offer on vessels. Those are the two that really shine in terms of customer feedback and how they enjoy that. With a catamaran, especially on a 48 volt, you're able to deliver obviously a lot more watts at the higher voltage. And the majority of our catamaran outfits are at 48 volts. And it really changes what you're able to do when you're cruising on a catamaran, in that when you're underway using the motors and not the sails, you're essentially limitless in power within the boat to the point where you're also charging the battery bank. So that means that anybody that's inside the vessel, you can run the air conditioner, any other high draw appliances. I mean, there's no limit to the amount of power that you have, as opposed to running a generator. Now, and here is another interesting trend. We've had a lot of people order their boats brand new out of the factory without a generator, which was unheard of in the past. But now, with the Arco Zeus and the high output alternators that they've been providing, you don't really necessarily need a generator, because of the amount of power that you can extract out of those alternators, you can charge that bank really fast and then use the battery bank to supply your needs till the next time that you move the boat, and or just start the engines and use them as generators. So it's been a very big game changer in the marine world. I mean, high up alternators hasn't really been a new thing, but the way that Arco developed their product and the way that the user can interact with and look at the data, everybody's become so familiar with the Bluetooth app that Victron offers, and looking at, you know, the wattage that you get from the solar panels, etc. Arco has now introduced that in the alternator world, and it's been very well welcomed.
Yeah, that's awesome. That's impressive. And in terms of the, you know, not needing a generator, that's something that we're starting to see as well. In fact, I've heard this term start floating around, genless RV. And so it's still kind of, I think, in the earlier days for that sort of thing in the RV world, but certainly seeing that pick up.
Absolutely.
But yeah, thank you, Andre. And if you're watching this either here today or on YouTube and have anything marine, catamaran, yacht, boat related, definitely check out the Yacht Rigger.
Thanks, Kaza.
Okay, so we're about to walk through a typical secondary alternator system overview. But first, I'll take a moment and share our process when you're considering this direction. Say you've determined, hey, DC to DC charger isn't quite right for this particular project. We want to do a secondary alternator installation. So first, we start by making sure that you have the proper mounting kit and the necessary diagrams. All the accessories, our SOP documentation, everything to set you up for a successful install. At that point, it's on the installer to make sure they've reviewed all of the documentation and that they understand the SOPs fully and follow those to a T. Of course, we're available throughout for questions and support. But you know, you may have heard horror stories or experienced this yourself, accidental damage to a secondary alternator. It's been a fairly common thing, especially for new installers. But with the SOPs that we're developing, that we've developed with input from Arco, from Victron, and other industry experts like Andre, it's going to be much easier as a professional to start working with secondary alternators and offering these as an option. But with that, I'd like to pass it over to Dan, and we'll take a closer look at what a secondary alternator system looks like.
All right. Thank you, Kaza. So just taking a high-level view of the system and the primary components that you have in any installation. These four here are going to be necessary for all installations. So we have Arco shunt, which will typically be placed on the positive run from the alternator, and an NMEA 2K, NEMA 2K terminator. This will ensure that the CAN messaging is terminated at the end of the chain. The other end, that is, would be an RJ45 terminator in the VE CAN port of your Servo GX. And on a VE CAN chain, or just any CAN chain rather, you're able to place a lot of devices. So in a Victron system, you might have MPPTs, or a Lynx Smart BMS would be most common as well, with VE CAN ports that would be in that chain. And then the Zeus regulator itself, it comes with a control and battery harness, as well as the alternator harness, a thermistor for alternator temperature sensing, and a battery temperature sensor. And then lastly, we have a Balmar APM. It's an alternator protection module. And this is recommended in all installations. And a little later on, Peter will get into why this is used. Okay, so as mentioned, the alternator does come with a couple harnesses, one for the alternator and one to go to the battery bank. You've got a couple choices as far as the length, there's a 6-foot harness, and then there's the 15 and 30-foot harness, 15 for the battery bank or the battery harness, and the 30 feet for the alternator. Certain regulators might require a specific harness depending on the type of alternator that the system has, whether it's P-type, N-type. With the Zeus, though, the only consideration is, do you need an extended length harness or a standard length? So depending on where it'll actually be installed and what you're installing it in. All right, and this is just a nice little visual, kind of showing why you might choose between the extended harness or the standard one. As you can see in this application, looks like a camper van. Maybe the battery bank and Zeus are all the way towards the back, and of course you got to reach all the way up to that alternator in the engine bay. So a 30-foot may be applicable depending on turns you got to make, things of that nature. So it'll just sort of depend on where things end up in the install. All right, and so these are the 3 primary components that are communicating with each other in a secondary alternator system. You've got the battery bank, the alternator, and the regulator itself. So on the alternator side, mounting kits are specific to the vehicle chassis, and the alternator housing is also going to be specific to the mounting kit being used. And really want to stress this, the alternator voltage should match the system voltage, so that if you're using a 48 volt alternator, battery bank needs to be 48 volt. And alternators are going to be designed for either idle, low speed applications, kind of like Kaza mentioned, like a mobile medical, like mission critical sort of thing. Maybe you're spending a lot of time at idle RPMs, so that might be a better application for that. But then also high idle or like cruising speeds at highways. So choosing the right alternator for your application is important as well. And then on the battery bank and BMS, a few things we need to understand. Does the battery have an internal BMS? Does it have an external BMS? Do we have closed loop communication between the BMS and the regulator? And again, just want to confirm that the alternator voltage matches your battery bank voltage. And now I'm going to pass it back to Peter, who's going to dive a bit deeper into how to set these systems up.
Awesome. Thanks, Dan. All right, so we're going to kind of start a kind of like a system overview of some of the wiring here. And so this image right here to the right on the right side of the screen, and this is a diagram provided from Arco. And this is the wiring pinout for the alternator harness. This goes from the regulator to the front of the vehicle or wherever the engine bay is to the alternator. And right here we're taking some measurements with these connections. So right here, kind of at the top, we have the alternator tach, the tachometer, and what this is, is the engine on? Is the engine on spinning the alternator, and is the alternator communicating our RPMs back to the regulator? Under there, we have a temp sensor. This is going to send the temperature of the alternator back to the regulator. We're keeping tabs on that alternator temp, and if it gets too hot, we're gonna shut it down. We're gonna stop charging. This is one of the safeguards in place for the alternator. From there, we have alternator V plus and the alternator ground. This is where the voltage is measured at the alternator. And on this V plus, this is going back. That's that connection to the alternator right there. And I just want to make interject there and say that alternator shunt mentioned before, that Arco shunt, is placed on the main cable back to the battery bank on the positive line typically. And in this case, the shunt is being used as a power meter. Then from this, we have the alternator field, and this signal comes from the regulator, and it excites the alternator rotor. If the regulator says all systems go, then the field current is sent to the alternator. depending on the signal sent, the alternator will throttle or ramp up its output. So that's one of the important connections there. And here we're onto the control/battery harness. And on this one, there's quite a few more connections on here. So we'll go through these. And for some of these connections, depending on whether you're using an internal or an external BMS, this will inform which connections are being used. So kind of going down from the top of the list, we have an ignition signal, and that needs to be tied into a circuit that's live when the ignition is on the vehicle. When the vehicle's off, that ignition signal should not display any voltage. And that's also one of the kind of safeguards within the Zeus to make sure that we're not going to excite the alternator if the vehicle is not on. The next, enable ATC input. This is an important one to consider. And when we're using Victron Smart Lithium batteries, we're using an external BMS there. So we might be using the VE Bus BMS or perhaps the Lynx Smart BMS. And the Lynx Smart BMS is a very common one that we see because of the way that it kind of handles this ATC signal. And we'll talk more about that in a minute. And then moving down to the battery shunt connections. So there are two shunts in this system. There's one on the positive output of the alternator that's going to show us what the alternator is outputting. And then there's a battery shunt in your battery system. For systems that do not have a Serbo GX, you will connect these battery shunt cables to the shunt that's in the system. And we'll get to that in the next slide. We'll show you a system overview. For a system with a Serbo, these battery shunt plus and minus are not needed. And then so after that, those battery shunt connections, we go down to the alternator shunt connections. And this goes to either side of the alternator shunt. You'll see if you take a look at it, there's two connection points for either of these. And then this is also to measure the current that the alternator is outputting. We're using it as a power meter. And then the battery ground, this is going to connect to the negative or ground terminal on the ground bus bar, as well as this BAT-V plus. This is going to connect to we're going to have this connection at the Lynx distributor typically. And kind of a Zeus pro tip here, if we're working with a 24 volt system or a 48 volt system and we're charging with a Zeus, providing 12 volt power to the BAT-V plus and battery ground, regardless of the voltage we're going to charge with, but providing power to the Zeus regulator with 12 volts is very ideal. And because we've seen a few situations where that has kind of smoothed out some rough communication in there, and that the Zeus likes to operate on that 12 volt. All right, now we're into the system overview here. Right here, this is a basic diagram from Arco displaying the connection points from the battery harness and the alternator harness. Here, we can see to the left of the alternator, we have that alternator shunt up there. That's that Arco shunt, that 500 amp shunt that we showed earlier. And then those are those two alternator shunt wires coming off of that go to the Zeus. Over on the left side of the diagram, I'll point out we have the battery shunt there. And this one does have those battery shunt plus and battery shunt minus cables going to the shunt, so we can get that data into the Zeus. Like I mentioned previously, if you do have a Serbo GX in the system, that will communicate it to the Zeus. And one other thing I want to point out here is the battery voltage sense is on the system side of that battery disconnect switch. And we'll talk about a little bit more about that in a little bit.
Yeah, real quick, I'll jump in on that piece as well. So That's very important where you put the battery voltage sense. You don't want it to go directly on the battery. It needs to be on the system side. And for those of you who use a Lynx distributor, it should be on the load side of the fuse as well, so that if that fuse ever blows, if we think about a Lynx distributor, the fuse lands, one side of it's on the positive bus bar, the other side of it goes out to the alternator, right? Or whatever our load or charger is. And in terms of placing this V positive, it's really important. The placement of this is one of the more important things that you'll do in this install that could lead to disaster if it's not done right. You want to put that on the load side of the fuse. So again, in the event that fuse blows, it no longer senses voltage in the system, which tells the regulator to wind down the alternator. It says, hey, stop charging, because if we keep charging, we'll talk about this here a bit here more in detail in a sec. But if the alternator keeps trying to push power and there's nowhere for it to go because the fuse is blown or the disconnect switch is off or whatever, that's bad news.
All right. So this is still with the system overview, and this is kind of a zoomed in shot of how we would connect a Serbo GX and a Lynx Smart BMS in a system with a Zeus. Two things I want to point out are the RJ45 terminator at the Serbo, and then that NEMA 2K terminator at the Zeus. Those are crucial to get it the proper communication in the system. And so do that with every CAN bus on there. And one thing I want to highlight with this Lynx Smart BMS, and if you look under that, you'll see this little wiring diagram where we see the ATC output of the Lynx Smart BMS is jumped a few spots over to the relay, to the common of the relay, and then from that normally open connection from the relay, that's what's going to connect to that ATC connection on the battery harness. And when we wire it like this, there's one more setting in Victron Connect on the Lynx Smart BMS that you need to make sure that you enable, and that's the relay mode set to alternator ATC. Something that's really awesome about this feature that Victron has integrated is that this ATC signal, when it's routed through the relay and this mode is selected, if you were to tell the BMS to turn off in the Bluetooth app, that ATC signal through that relay is going to be cut 2 seconds before the contactor in the Lynx Smart BMS opens. So what that's going to do is going to allow the regulator to ramp the alternator down. So we're not shutting the BMS off, shutting the system down, and that alternator doesn't have any place to, no path for the electricity coming from it, so which can lead to damage. That's why this is a very awesome feature that is in the Lynx Smart BMS. This is how the Zeus connects to the Serbo when a Lynx Smart BMS is not present. So with the Lynx out of the picture now, what safety feature do we lose here? And that's that ATC relay. So yeah, let's discuss a situation that may occur while the system is running. So what happens when the battery disconnect is switched off and the vehicle is still running? Or another situation would be if the internal BMS shuts down and the vehicle is still running. Kaza, do you know what we would say here?
Yeah. So the vehicle is running and the battery disconnect switch is turned off. So that could be really bad news. If what happens is the power that the alternator's producing, and I think I kind of alluded to this here a moment ago, it has nowhere to go when that disconnect switch is shut off. So if it happens very quickly, then while the vehicle is running and while a lot of that power is feeding into the battery, thousands of watts, if that's shut off immediately, well, there's going to be a backfeed and there's going to be a surge that can go back into the alternator and that can damage it, and in many cases will destroy it if if that happens, if you're running at a high speed, you've got a high output coming out of the alternator, and all of a sudden it just gets turned off. Luckily, there are a number of ways to kind of mitigate that risk and design a system in a way that if that were to happen, it's not a disaster. The Balmar APM. So this is a very useful product to install in all applications. When you have an external BMS and you have that the communications with the Lynx BMS in particular, that will ensure if in the event that the disconnect needs to be turned off, whether you do so manually or your customer does so manually because they just don't know any better while they're driving, they turn off their main disconnect just because they want to conserve power or whatever, they just didn't know. Well, lucky with the Lynx BMS, it has that feature where it will shut the alternator down first before the contactor opens between the battery and the system, so that now you have that safeguard in place. Even still, it's a good idea to have a Balmar APM. These come in 12, 24, 48 volts. They're pretty inexpensive. I want to say each one of those models is under $100 or right around. And what happens is in the event that ever does take place, where you get this giant surge going back to the alternator, it's kind of similar to a surge protector in the sense that now you have protection and it will absorb that, and it will need to be replaced after that happens. It has a little alarm that will beep at you, and so you'll hear it and know, oh shoot, something happened, we need to get this thing replaced. But then you can do so without too much trouble, and it saved you, well, whatever the cost of replacing the alternator would have been, which is probably significantly more. In terms of placement, you want to make sure to place this on top of the cables that are on the alternator, right? Not underneath, otherwise it won't work as intended.
Right, we're talking about the lugs that connect to the alternator on top of.
Okay, and then we'll go the other way around. I'll ask Peter, what happens when the battery disconnect is off, but you have an MPPT or you have something else in the system that's providing voltage? And now, again, we talked about where you put the battery voltage sense for the regulator is very important in terms of letting the regulator know, hey, we're good to charge. But now the battery disconnect switch is off, but we still have voltage throughout the whole system because we've got a solar panel on the roof. There's solar coming in. Somebody forgot to turn off their solar disconnect switch. So, that happens. We've got power on the system. So what's going to happen now? Or how can we mitigate this risk?
Right. So in this situation, the batteries being off, we have the voltage sense reading for the battery bank on the system side of the switch, which we're not providing any battery power there, but if we have PV incoming, that's providing voltage there. That could be seen by the regulator as, hey, the battery bank is connected. So a field could be sent to the alternator, potentially if the vehicle was turned on. So these are two main disconnect switches, the Marineco 771 SFD and the Blue C 3001, which when you turn the battery bank off, there's a connection on there that you would route from the alternator field wire to the switch, and then from this switch to the regulator that also cuts the field when you turn the system off. So even if there is PV voltage coming in and the battery bank is off, this will make sure that there's no connection with the field. So
and this is primarily for systems that have internal BMSs.
Right.
If you have a Lynx BMS, you don't need this. But if you don't have a Lynx BMS, even if you're using another external BMS like the VE Bus BMS or something along those lines, it's really imperative to use one of these switches so that in the event the disconnect switch is off, right? What's the thing? What are we solving for? We're solving for the specific circumstance if the main disconnect switch is off and solar is for some reason still coming in and providing voltage to the system. We want to be able to ensure that the regulator doesn't send power when it's not supposed to. And the only way to really do that is to use these switches in the system.
All right, so before we get to programming the Zeus, let's talk about kind of how to avoid damaging the alternator. So, do not rush the install process or bypass any of the steps before you engage the whole system. And so we kind of look at, can you turn the vehicle on? No belt on the alternator? No. Main battery disconnect switch off? No. No fuse in place at the links distributor? No. Wiring hasn't been double checked? No. We want to make sure that we've covered all of our bases before we engage the entire system. One note here is if you must move the vehicle before the entire install process is complete, make sure you disconnect the harnesses from the Zeus. This will prevent a field signal from getting to the alternator. So let's move on to programming. So with the Zeus, there is a Bluetooth app. You can find it wherever you download your apps, and you don't need to have a Zeus to connect to kind of scroll through the app. So I recommend everyone download it and kind of get familiar with it. So when you open up the app and you select Begin New Setup, it'll walk you through the install, kind of the install process step by step, and then it'll kind of bring you into programming. Conveniently, the app has a library to select alternator brand and model, as well as the battery brand and model, which is going to pre-fill many of the settings later on in the app. So that's pretty helpful there. And if your battery or alternator are not on the list, then you will have to manually input all the parameters. So there are many settings in the app, and we're going to go over some of the key settings and some things not to overlook. All right. So what we have here on the alternator info page, there's a couple settings here. Tack poles. How many does the alternator have on there? Many alternators have 16. Arco alternators have 16 tack poles. This would be a pre-filled parameter if the alternator is chosen from the list, but always good to verify and double check. And then like I was saying, if your alternator is not in the library, you'll have to fill this in. And another setting, drive ratio. To get the proper drive ratio, which we take the crankshaft pulley size, divide by the alternator pulley size, and that's what we get for the drive ratio. And then on the battery info, voltage, set the voltage, amp hours, and the max charge current. And then on below that, we have the shunt rated amps, the shunt specs. And that'll ensure we're getting the proper readings. And so before we connect the Zeus harnesses to the regulator, we want to make sure that the battery system is off, because we don't want, if the harness is live, there's a potential for an arc when we're plugging it in. This could damage the Zeus circuit board or possibly the connectors. It's an easy situation to avoid, so let's all take this step. Yeah. So we're at the point where you get the system wired up, the system's off, the harnesses have been connected to the regulator. We've entered our battery information and our alternator information, and now it's time to power up the regulator and finish the programming. So remember, the vehicle has still not been turned on yet. So we kind of go through the checklist of the alternator is installed, the new belt is installed, the battery and alternator harness are connected to the Zeus, everything's fused per the diagram, and the system connections are made. We've fused at the links distributor, and we've double checked and verified all the connections match the wiring diagram. And then we can turn power on the battery system, and that's going to activate the Zeus. And then on the Bluetooth app, it will detect your Zeus unit. And so we're going to go through some of the settings on here that are key to follow. Under the battery tab, battery temp sense. Enable this if you're not using Victron Smart Lithium and we're not communicating through DVCC on there. Alternator tab, startup delay, ramp to bulk, max engine RPM, and RPM limits. Those are some things that are going to be kind of specific to the chassis you're putting this into. And if that vehicle has any limitations with our RPMs, or you can kind of delay once you start the vehicle up, let it warm up a little bit before the Zeus engages its charging profile. One setting here, the duty minimum. For Arco alternators, it's good to set a 5% duty minimum. And what that's gonna play into this over on the regulator tab, this TAC required setting that makes sure that the alternator must be sending a TAC signal for the regulator to engage. So in order for that to work properly, we'll enable TAC required, and then we have to set a duty minimum to 5%, which sends a very small field current to just barely excite the rotor, but not rotate anything, not get that in motion. And then in the charge profile, this is where we're going to set the absorption voltage, float voltage of the battery. And then on the regulator tab, we're going to enable the ATC input. This is also where the NEMA 2000 and RVC communications are, as well as the different sync modes, the follower modes. And we'll be setting Victron follower in our case. We're going to go over a few important settings on the regulator tab. And for the CAN communication to the servo, we want to enable all three NEMA 2000 messages, as you see in this image to the right there. This will set up the communication for the system. And then, like what I was just talking about, TAC required, make sure to enable this setting. This ensures that charging will not begin until a TAC signal is received. And with the Victron BMS, we want to make sure we enable ATC input because we have that allow to charge signal going to the regulator. And below that, we have the sync mode. And the sync mode will be set according to the BMS control. In our case, we have the Victron Smart Lithium. We will set it to Victron Follower. And then this will enable the Zeus to be controlled with DVCC. And in order for DVCC to engage, you must set a battery max charge current. That's determined by the number of the battery spec and the number of batteries you have and how they're wired in the system. And for that as well, an alternator shunt is required. All right, let's go to the final checklist and before we turn the system on. So once we're ready for the first system start, we have stuck to our SOP and we've gone down the list. The alternator's been installed, the wiring is complete, all the connections have been verified, the Zeus has been programmed, and now it's displayed on the servo device list. And we have the house battery, the house system turned on. Now we can turn on the vehicle, and now we can see how it charges. Go down that list and check those off.
Yeah, I missed these check marks. And now we're charging, and now we're doing it safely, and we're not destroying an alternator en route to success. If you guys want, if you're a professional, right, and you want access to, I mentioned the tech guide and the SOP documentation that we've developed to run through these installations. We'll have a slide at the end with a QR code where you can kind of express that interest. We're not making this documentation available to everyone just because we don't want folks to get the wrong idea. This isn't really a project that a DIYer should be thinking about. You really need to know your stuff if you're going to be installing a secondary alternator. So yeah, we're getting close to releasing that, and we'll have an opportunity for you to express interest in getting those. Okay, so I've had the pleasure to work with Arco for the last few years now, and they asked if I would sit on the advisory board and help with the development of the Arco Zeus regulator. That's where I worked alongside Andre and a few others to offer a bit of guidance and make some feature requests. And well, now we're a technical distributor helping professionals with system design and installation. Zeus has been on the market since 2023, which is relatively recent, but Arco has been around for over 60 years. So these guys, they know alternators, they're innovating in the high energy output space, and well, they're here with us today to share a bit more about their new lineup. So Ben, Nick, thank you guys for being here, and would you like to take it?
Yes, absolutely. Dan, Peter, Kaza, thank you so much for having us. This is a real honor and a real pleasure. Andre Cormier, also wonderful having you here as well. As Kaza mentioned, he was on our technical advisory board, as was Andre Cormier, a couple years, or maybe it was 3 years ago now. But Arco had decided to not make just an engineering project out of this or a business case for our venture in getting into high output or high energy regulation, right? So we wanted to go tap some of the greatest, brightest minds in this field, and we were able to grab people from all over the country in all different industries and all different levels of I would say like being involved with the standard writing to in every case all 5 people in our board were and are business owners. So it's very important for us to not just work with people with like a technical aptitude, but also for people who are business owners who understand how it means or what it means for their company if there are these issues, or if they're always on the phone having to walk somebody through an installation of something or other. So understanding the kind of the pain points and working as many of those out of here as best as possible was what we were looking for. Kaza gave a great introduction for Arco in general, been around for over 60 years. Our first product was an alternator 65 years ago, and we've been in the business ever since, also with voltage regulators as well. We entered in what is a kind of the preeminent trade show dealing with equipment is IBEX, so it's International Boat Exhibition, and we won that 2 years ago. So we beat the likes of Mastervolt and about 26 other nominees, and we consider ourselves kind of, these guys to come up with a flagship product like this, and we're the kind of the mouse that roared, as we like to put it. So we're very thrilled. So we came up with the whole Arco Zeus line then. We are 12, 24, and 48 volt alternators. Okay, and I saw one of the comments there. Kaza had mentioned, somebody was saying, "Hey, watch out for the for the field percentages," and Andre had corrected or at least put a comment in there that spoke to what we do. We stick with 12, 24, and 48 source voltage fields. So what does that mean? If you had another person's product, say a Balmar or a Nations or something to that effect, you will, in some cases, have to sign something, and certainly you'll have to adhere to having a field or duty percentage no more than whatever 25% or 30% or whatever it is. But people can wind up in a bad predicament, and Peter went through like his checklist and going through a lot of this stuff. You can end up in a real predicament if you don't pay attention to what your field voltage for an alternator is. You can't necessarily say, hey, I'm going to go use 100% if you've got a 48 volt alternator. And like I said, a lot of our competitors, I can't think of any competitor who doesn't do this, but use a reduced voltage for their field. In other words, a 12 volt field, a rotor on a 48 volt, or a 12 volt on their 24 volts. So you're always having to do the mental math and doing okay, I got to have this, or no, I've got to go quarter this sort of a thing. So it is a real big thing when you're dealing with that. So whoever came up with that comment there, that's a great point. You always have to watch for that and double check with your alternator supplier. Ours are the as I say, if it's a 48 volt alternator, we're using 48 volt fields. If it's 24, we're using 24. So you can always, within the Zeus regulator, you can always use 100%. It doesn't have to be reduced. Okay. Yeah. So one of the points here is we may have time for some slides here, but In short, we're about 8 to 20% cooler than competitors, and we range anywhere from around 8 to 30% higher power production for a given RPM. Okay, and we have some empirical data to go illustrate this as well.
Ben, is real quick, is
Yeah.
the rotor voltage, is that a consideration or one of the reasons that the Arco alternators are run cooler and
Yeah.
run more efficient,
Yeah.
because that rotor voltage is native to the system and you've got less
Absolutely.
amperage and that kind of stuff?
Absolutely. So again, the competitors will put in like what we call in the industry like a hot rotor. And so they're making this, they're juicing this 12-volt rotor in order to go accommodate like this 48 volt or this 24 volt. So they're putting a lot of I guess power, heat and whatnot through that in order to go 24, 48. Okay. Yes, so that's a great question. This is the family, and we're doing this in watts just so we can put our 12, 24, and 48 in here. But we actually have one more 24 volts over here. You'll see in another slide. But one thing to keep in mind is we're always, whenever we're looking at these graphs, we're looking at this in terms of alternator RPMs. And actually, this is this is an older slide. I should have given you an updated one. This is another, and I will give this. This was one of our first actually 48 volt entries, which is a 5.5. Right now, and perhaps we have it on another slide, but we actually do 10 kilowatts cold. But it's our A8000, and I think we've got some data on here. And our 24 volt, we actually have two as well. So I'll update that slide, Kaza, so you can have that perhaps for like the, I don't know, for the recording or for the final presentation. But we can move on from there. All right. So here are a few competitors in this A275L. Now, again, over on the y-axis or on the left, these are in amps. I think I find oftentimes in 12 volt, people are talking about it in terms of amps and less watts. The higher you go in voltage systems, people are talking about it more in terms of watts. But we are the ones up on top. These are hot curves. This data is available on our website. If you went to our A275L onto Arco, you can go down and look at support and downloads, and you can take a look at test results. And you can take a look, and there's about a 23-page, basically white paper of what these tests entail. In short, this is running after 1 hour at 3,000 RPM with a heat shield over each of these, and then running a sweeping test at the very end of that 1 hour, and to see at all these different alternator RPMs how these perform. Okay. Kind of enough said there. All right, now this is the 48 volt. This is the A8000 that we're talking about. So, and this is the other slide that we showed. That is all of everybody kind of publishes what one manufacturer says is a hot test is not necessarily another manufacturer's hot test. There's no standardization. So that's what we did in the other slide, was to kind of say, hey, apples to apples, we want to put everybody through the same rigors. This is taking everybody's their marketing data against our hot curve. So up at the very top, sorry, it's pixelated. I know this didn't translate that well for going from Microsoft to
yeah, I'll put the slides, I'll make it available, and we'll be launching a blog post to coincide with this presentation, and we'll make the slides available. They'll be crisp.
Yeah. So you can see we are the tall, like the higher one up there, the dark, either whether it's black or a navy blue or whatever. That is our A8000 curve. One of these divided kind of lines, this dotted line going down, you guys are probably familiar with the Mercedes Sprinters, and that is the idle line. So when you turn it on, it's a 3.21 pulley ratio, and you're at about 750 or so speed idle, and that is showing you what you can do at that idle speed with that. Again, these are all alternator RPMs down at the bottom. That's where you are, okay? I am taking into consideration, these are everybody's marketed, this is their distributed curves. You'll notice a lot of these curves are cold. It is cold up until it runs for about like a minute, and then it takes on a considerable amount of heat, all alternators. And then it effectively, you'll hear a lot of people say it deregs. I don't know if it's not like going through a regulator dereg, it just is heat is the enemy of a electrical field, really. So they all come down. So so to put it mildly, like this is the best that all of these curves will look, especially the ones that say cold. Okay, APS has got a hot curve in there, and their marketing is extremely accurate. I don't think it would actually deviate much at all, if at all, from what APS says. So they're hot curves. But do take a look at the other cold curves again. This is the best that it'll look like. So yeah, you're going against whether it's a Nations, and Balmar has got two different versions. It's very common for a lot of the alternator companies to have two different versions. And somebody had mentioned, it could have been Kaza, just at the very beginning, saying you really want to look at what is your use case. I think Kaza, you presented at the very beginning two different sort of speeds. This is at a cruise speed, this is at a lower cruise speed, or at an idle. So know your use case for this, and oftentimes other companies will produce two different alternators. It just so happens that like our one alternator basically shadows all of the different use cases basically from a lot of the competitors. Okay. This is some of the main differences. There are three slides that kind of go back to back to back here, and I will go through this as quickly as possible. There's an Arco Zeus, APS, and a Nations. You might see there are some stark differences right at the get-go. There's a tremendous amount. It starts with the airflow is what cools down a lot of this stuff. And if you were to take a look at the aperture here, how much opening that the cover has, it's kind of illustrative of the command that any manufacturer has of the importance of this airflow. So we put a lot of emphasis on this. Okay, so now we're going to remove these covers and take a look at what these look like. Okay, so starting at the right, and we'll get over to the Zeus in a second, but you can see which way this is going to go. But this is this Nations alternator. That is a rectifier over there. If you guys aren't familiar with the rectifier, I'd be happy to talk with you guys afterwards. But this is a tremendous heat source. So stator is a big heat source. The rectifiers, where the diodes, is where it's taking AC to DC power, and it generates a tremendous amount of heat. Okay. If you were to take a look at that at the right, and you're taking a look at the upper right hand, first of all, if you were to, with all three of these, if you were to shine a light through the bottom here, so you can take advantage of those covers that we just took off, and you were looking at the airflow coming in, if you were to shine a light, you would not see any light coming through the Nations, except for maybe a couple little holes there, right? You would not see any light coming through the APS. There is effectively no airflow that is coming through those covers directly down into the rotor and the stator area. It's not passing through the rectifier. It's passing over. If you take a look at ours, look at the amount of surface area gained. And if you were to have a light, or if you were to submerge this in water, you'd have all this water coming up. But you would see these are all just like an incredible amount of surface area, which is a tremendous amount of cooling power. Okay. And open, not just with that surface area, but the opening to allow air to come through and get sucked into where the rotor fans are driving everything. So if you take a look at like the lower three, you've got a stamped steel there. You've got a casting with the with this one in the middle, which is slightly better. And then again, you see the Arco Zeus. Okay, and again, you would just see air, and the airflow would just go through like mad. So it's just good design. And if you were to take a look at these stacks that they have in the stator, we use a much different sort of a stack. If you were to take a look at this, you can go on our website and to see how sophisticated the stator wind is. Again, with some of the competitors on the right, take a look at, you can only imagine the sort of airflow that you're going to get out of that, right? It's basically occluded with a bunch of like cumbersome copper, blah. But these holes there, you're not moving a lot of air. Same thing with the middle of the APS. Looks like there's slightly more room for air to come through. And ours, it is just like unoccluded, basically, right? So just sourcing wonderful components, having great engineering that just starts with the very base principles is no wonder. Like this is how we're getting 80 to 30% out of more performance and a much cooler package with our products. Right? I don't know.
Yeah, this is great, and when I first shared with Ben and Nick that we'd be doing this webinar, they kind of asked, well, what should we talk about? Like, what you guys are going to be focusing on the regulator and the SOPs and the documentation and things like that. And I told him this, like when he showed me these slides, the power curves and the open air design, between these different models like that kind of blew me away. So yeah, I'm just glad that you guys were able to join us and share a bit more about this, and hopefully we'll be able to hang on to them for a little bit longer for our Q&A in case we get thrown any curveballs. But yeah, thanks, Ben.
Absolutely. Thank you, guys.
So we're about to get into the Q&A. Before that, just real quick, we are developing kits for Arco and Victron to work well together. The Arco kits, they're going to, in the beginning, focus on Mercedes Sprinter, Ford Transit, Ram ProMaster. There's going to be a 12 volt, 24 volt, 48 volt options for all of those platforms. The kits will include the mounting bracket, the Arco alternator, the Zeus regulator, and then again, the documentation that you'll need for a successful install. There will be support for additional vehicles upon request. We work with a bracket company and can get most. It depends on what the application is, but there are many that are readily available. But yeah, before we get into the Q&A, we do plan to share a gift with everyone who joined us live today. So please stick around for that. These kits, I don't think I mentioned, they'll be available probably in the next week, 1 to 2 weeks. That's kind of the timeline we're looking at. Yeah, let's open it up. If we have a few in the chat that we'll get to, but if you have a question, please raise your hand so that we can have a discussion. What do we got? TJ, I just selected you. If you can unmute.
Hey, yeah, can you hear me?
We can.
Awesome. Thanks for all the comprehensive information, everybody. Something that I'm not so familiar with is the NEMA 2000 communications. And I know that you've mentioned like installing that terminator to close the CAN network. So can you like elaborate more on how VE-CAN and NEMA 2000 relate? And are they just like kind of different ways of BMS communication, or is there a reason you might want to use a system that uses NEMA 2000 or VE-CAN?
Yeah, so the NEMA 2K messaging is once that's enabled, the communication runs through the VE-CAN channel. So the NEMA 2K messages, as long as those are enabled, will be received and properly interpreted from the Serbo GX through the VE-CAN channel. Does that sound about right, Nick? Do you have anything to add?
Yeah, I was gonna say like, yeah, just so like at a very high level, the VE-CAN and everything Victron, as far as like BMS CAN and VE-CAN and everything else, it's all NEMA 2000. And Victron just built their proprietary protocol on top of it. So if you select, for Zeus, NEMA 2000, it's what Victron's communicating with. The only thing that's different is like the VE direct ports. Those are a serial-based protocol, but anything with the CAN in the name of it on Victron products is NEMA 2000.
Awesome, thank you. That clears a lot up there.
Nice. Thank you, TJ. Okay, I got another hand here from Kenny. Kenny, what's happening?
Yeah, I asked this quote or the question in the chat, but could the Valmar be placed at the links, or does it have to be directly on the alternator?
The APM, you want it directly on the alternator.
Okay.
So like for our units, we have the dedicated ground post and the positive B+. You just put it right on the alternator, right at the source.
Okay. Makes sense.
Awesome. Thanks, Kenny.
Amanda had asked, is there an integration with EcoFlow?
So yes, it's almost finished. Well, let me say it is finished. It'll be coming out in our next update, which will be um, we're starting the process next week. We always start with an app update first and then the firmware update. In this case, the app update has a lot of new features in it that I think a lot of people like. But yeah, EcoFlow is in it. We've been in it, but they've just been kind of revising their system and improving their process, improving their comms. EcoFlow is fairly new to using RVC communications, so they had some kind of bugs to work out. So the short answer is yes, we have an integration with EcoFlow, but there's always a caveat. However, EcoFlow systems they're not, they design their system to be proprietary, meaning they don't follow like Victron's CAN bus pinout or anything. So we followed Victron's pinout just to be plug and play compatible with Victron equipment. So if you do an EcoFlow system and you want Zeus integrated with it, then you need their proprietary, I think they call it the power link to Zeus regulator cable. And so they are the ones that have that. You'd have to get it from them, and that converts their comms over to us. But yeah, that's the only real thing you would need to connect to Zeus. But yeah, it's there. You just have to get. I'm not sure who controls that for EcoFlow, but I'm sure if you had like a supplier or distributor or somebody like that, they'd probably be able to provide you information about it.
Nice. Thank you, Nick. Dan, did we have any other questions in the chat that haven't been addressed?
Yeah, Jake had a good question in the Q&A here. He asked if we use an internal BMS battery that is communicating allow to charge, allow to discharge status with the servo via CAN. Is the servo smart enough to communicate that status to the Arco in place of the Lynx BMS alternator allow to charge feature?
Yeah, so that's actually a really good question. So yeah, like Victron's Lynx and the Lynx NGs, and I think there's only one other BMS out there that I know of that has the ATC relay. Everybody else has it in software on the internal BMSs. So the unique thing with Victron is they do have that relay, and it all comes down to like priorities for the BMS. So for Victron, if there is a action that we need to, take part of, there's something, if there's some event where we need to stop charging, the very top thing they do is when they say, okay, we have an event. The second thing they do is they flip that relay. And then they go through their process. And then in that process, somewhere between flipping the relay and turning off the BMS, they send out a CAN message that says, hey, don't charge me. So they do send out a CAN message. All batteries do. It's just everybody has a window, and it's supposed to be up to 3 seconds before a disconnect. The added benefit of the Victron systems, they have the relay that happens, number two thing that happens is they flip that relay. So we know what's going to happen closer to that 3 seconds. Some systems we've seen do it 1 second before. That's really like the shortest window we've gotten. But it's with anybody else, it's a window that we get from 1 to 3 seconds. With Victron, it's like 3 seconds because we flipped that ATC relay. So yeah, we do get it over CAN bus, but it's just sooner in the process with the Victron BMS.
That's awesome. And what that touches on, again, we talked about, well, what happens if you shut off your main disconnect switch while the vehicle's running, while the alternator's outputting a substantial amount of power? Well, this is what we're talking about here. And in this case with Victron, we've got a few more seconds that the alternator, that the regulator, that everything has to kind of respond and wind down before that contactor opens and, well, can create a giant spike in the system.
Yeah. Yeah. I mean, not to take away from other systems and their CAN buses, because it does work very well. It's just always nice to have that 3 second heads up versus 1 second. So
totally. TJ, yeah, what do you got?
You mentioned earlier if you have a Lynx controlled system and you have a Victron MPPT in there, then you don't need to worry about the MPPT being left on when the battery switch is off. Can you elaborate on how exactly that works? Like when you select the alternator ATC, does that control the MPPT and prevent it from leaking voltage that would then in turn give the field a positive signal?
No, with the link system, and I might lean on Nick a little here as well to confirm this or just kind of touch on it as well. But with the links BMS, if the disconnect switch is off, then that you basically have that communication taking place so that the regulator knows that the disconnect switch is off and that it shouldn't be pushing power back into the system. Is that accurate, Nick? Do you know offhand?
If the
If the links BMS is off, but we have voltage that is present in the system because somebody left a solar disconnect switch on,
right,
and now the the V positive, if we're going solely based off of that,
right.
sees that there's voltage present, is it going to allow the alternator to
Well,
charge while the disconnect switch is off?
no, and no, it's well, and I think we're kind of mixing two installs or two setups here because if it were using we just call them just analog batteries. So in an analog battery setup with no communication, you would have that V-Sense connected and you'd have all the battery shut and everything so Zeus can know what's going into the battery and coming out of the battery. So that would be there and that would be connected. So in this case, like an MPPT could put voltage on the line and Zeus could sense it and all of that.
And in that case, real quick, that's
Yeah.
when having these disconnect switches that have that field interrupt, we should have had a diagram. I'll make sure that we include that in the blog post. If you go to either of those product pages, you'll see how it works. It's pretty simple. It's
Yeah.
really just an interrupt with the field, which is that's the last say that says, are we actually sending field to the alternator and exciting it so that we get a charge from the alternator?
Right.
So by
Yeah.
using one of these disconnect switches, when you have a battery with an internal BMS where you don't have these communications, well, now you can prevent that issue from happening where the disconnect switch is off.
Yeah.
And the system, there is a voltage present due to solar or whatever else, but it sounds like, Nick, with the Victron system, with the Lynx BMS, that's not an issue because if the disconnect switch is off, that communication is taking place and the regulator knows.
Right, because if your disconnect switch is off, Zeus should always be powered on the load side of your Lynx distributors anyways. So if your main power switch is off, Zeus shouldn't be powered on. But let's just go with the scenario that it is powered on. If we're in Victron follower mode and we're not receiving comms from a GX device or a Lynx, then we don't do anything anyways because we have no data to act on.
Well, that does kind of still beg the question of like, okay, what if the servo is on? Because it is being powered by, I guess it's powered by the auxiliary port, which
Yeah,
if
yeah.
which if
standby
the
mode on the links,
What's that?
like on the links, you put in standby mode. Does that provide power then to the servo if it's plugged into the aux port?
I thought we
not
tested
positive
Peter.
about that.
Peter, did we test that one in here? I thought we looked at that.
That's something that we need to figure out on that.
Okay, let's write that question down. We'll make
yeah.
sure to address it in the blog post.
The other fail safe, and the thing I mean, I just want to make a point of this because Kaza, with you and your team, you guys have like an awesome, foolproof, bulletproof install SOP that you guys have developed. So I just want to make a note of that. And like with that, like you guys have a lot of redundant fail safes, and so like with the switches. The main power disconnect switches that cut field and battery sense voltage and Victron comms. And if we're in Victron follower mode, we won't get comms. The other thing, and Peter touched on this in the presentation, was TAC required. That's another fail safe, and that is like the last fail safe because with Zeus having a minimum field or minimum duty of 5%, Peter touched on it, is Zeus will. If Zeus senses that the ignition has to be on, so your vehicle has to be running, right? For Zeus to even apply this. But then Zeus would apply a very small field, that 5%, like Peter said. And if we don't get a tax signal back, like an RPM reading, then to us, there's an issue. There's something wrong, so we're not going to apply a field. So if we get through all of the links BMS not communicating and the power switches not being on, like the last line of defense is that TAC required, which we won't apply a field unless we can tell that the alternator is spinning via the TAC signal coming back. So there's a lot of redundant fail safes, but this all goes into having a very safe system.
Yeah. Andre, did you want to weigh in on this?
Sure. I don't know how to turn on my camera here, but anyway, I've just had this exact scenario, interestingly enough, happen last week where a battery switch failed internally. So it wasn't a case of someone turning off the battery switch. The battery switch failed. And this system had MPPTs as well as a Victron inverter that acted as power supply to the main system. This was in the middle of the day. And the customer was actually, he's not a customer, he's an employee of ours. He was panicking a little bit because his battery bank was low and he wanted to get charged back into his system. So he fired up his alternator with the Zeus. Now, when he did that, the Zeus didn't really know any different because it saw voltage in the system. And it's not a Lynx 500 BMS. So I guess for all intents and purposes, it was not a smart battery bank. And it caused a voltage spike. The APM caught the voltage spike, but it fried his Orion TR Smart in the process. And then like right after that happened, we started diagnosing what happened and trying to find the culprit, which ended up being an old battery switch. That's why I like to use those Blue Sea HD 3000, especially the one with the alternator field cutout. But I guess this is a perfect example of what you're describing in a kind of different roundabout way where the failure happened.
That's there's not a whole lot you can do when it comes to a switch failing, and we've seen that too, where a switch, even a new one can fail and cause all kinds of weird voltage drop issues, and you're chasing your tail trying to troubleshoot and things like that. So we've got a bit of a process to try and rule that out sooner than later, because it can throw you for a loop if you don't see it coming. But yeah, I mean, it's all in the interest of like identifying every single loose thread that could result in a damaged alternator, because like there are so many things that could cause that. So we want to try and account for every single one of them.
Exactly. And you prepare with that, with your SOP. And like Nick was saying, just the steps that you take to try to prevent as much as possible. You never really know, some really odd failures like a switch failing can happen.
And that's why having the APM, even in systems like, Victron systems that have, some of these even more redundant safety measures in place, having an APM, again, pretty inexpensive and could save you a lot of hassle. Cheap insurance, definitely.
Guys, I just want to add, I looked up the aux port on the Lynx BMS. I found it in the manual here. They've got a nice little chart in section 7, and in standby mode, the aux port is still powered. But it does disable allow to charge and allow to discharge.
Oh, excellent. So in standby, allow to charge will be disabled, so we have no issues with that.
Mm-hmm.
Okay, cool. I know Ryan's hand has been up here for a minute. Ryan, what do you got?
It's about the Balmar APM. Do you still recommend using that with a alternator system that's communicating via CAN bus, or is, like you said, it's not really necessary?
Well, we think it's a good idea, and I know Arco, right? You guys, that's your position, right, Nick? Is that it's having the APM, whether you have comms or not, is again cheap insurance, just in case there's no real downside except for the extra 70, 80, 90 bucks, however much those cost. They're pretty inexpensive. Nick, your thoughts?
Yeah, I mean, it is like promoting a competitor of ours, but it is in the name of safety. And in the name of safety, we recommend it. So I would love to be able to offer you guys an Arco version. We're working on that. It's not available now, but we will be able to have one soon. But until then, we do recommend the Balmar APM. I mean, everything we do is about safety. We don't want to compromise safety. So yes, use one.
Okay. I guess one more, is the Balmar APM, is it guaranteed to work like no matter what, or is there any other kind of redundancies that you would recommend to just avoid, any of this happening?
I
Yeah,
think if you asked them if it was guaranteed, they'd probably say no, nothing's guaranteed. I wouldn't stick my name on anything to be guaranteed, but it's
especially for $80 or
Yeah.
again, however much they are.
Yeah.
So we've seen, and as Andre mentioned, it just saved them. It sounds like the alternator was fine. They might have lost a DC to DC converter, but we've seen it work, and so. Yeah, it's not guaranteed. I don't know that any of these measures are necessarily guaranteed, but when you do all of them, when you follow the SOPs to a T, when you make sure you really understand why those things are important, when you have an internal BMS and are using the switch that has a field disconnect, right? Like when you make sure the battery voltage sense is on the load side of the fuse, right? Like all of these things kind of come together, the SOPs to make sure you're not starting the vehicle at the wrong time. That's gotten folks just not knowing, and so like all of these things kind of come into play. And if you use all of them, then your chance of having an issue is significantly reduced.
Yeah. Yep.
Cool. Thanks, Ryan.
Sweet.
Andre, did you have something else?
Yeah, one more feature that I'd like to mention in terms of safety is the maximum voltage setting in the system. I always use that as a fail-safe because the Arco processor reacts very fast to the voltage sense leads, and I usually set it like 0.2 above the absorption voltage. So if I ever mess something up and the voltage was to creep up for any reason, then that is kind of like the last stopgap where the Arco Zeus is just going to reduce the field and not overcharge or overvolt the batteries. So I quite like that feature, and I've seen it. It saved me a couple of times. For example, that minimum duty, if instead of putting 5%, you put 15% by accident, you could definitely be in a position where you would overvolt the battery bank. So to have that maximum voltage is a really nice feature, in my opinion.
Awesome. Great insight. We'll take one more question because I know we've been here for a minute. I know you guys probably have other stuff to do. TJ, I saw your hand up. It just went down. So if you don't have a question, if anybody else does, or if there's one more, there it is. TJ, yeah, what do you got?
I just had a quick thing to add.
Oh, yeah, what do you got?
It seems like that Belmar device, what's the letters, like APC or
APM,
anyway,
Alternator
APM.
Protection Module. Yep.
Yeah. I feel like every system probably should have one of those in case the main fuse on the system blows.
Oh,
wouldn't
yeah.
that cause an instantaneous disconnect with no
Totally.
delay?
Totally.
So I guess I can't really see a reason why you wouldn't have it on there if your system
No, yeah,
has fuse
that's
like
a great
that.
point. Yeah, if you get a main fuse blown, there's not going to be any real time to communicate that to the regulator. So yeah, very very good point.
Yeah, the
thanks
thing
for
with
everyone elaborating on that.
the thing I want to add to that too is some people see it as, and maybe it's just because of the way that other alternator manufacturers have done it before or how they do it, but our alternators, when we design them, we specifically design the components in the rectifier that Ben was talking about earlier, that back metal case on there. All those diodes, we specifically spec them with our alternators. So if you don't have any protection and there is a disconnect or some event that stops charging, we specifically designed the alternator to take the brunt of that force and the diodes to pop. Like, does it ruin the alternator? Yes. But in the grand scheme, that is probably one of the least expensive components in the system as compared to the whole power system itself. I mean, one alternator doesn't even come close to a Victron inverter. I mean, so I'd rather, yes, it's a high output alternator. It's not cheap, but it's designed to, at the last ditch effort, all right, just take it itself and take the brunt of the force and absorb it. The ATM APM really is what it's similar in nature and design to our rectifiers. So it just sees that spike and just takes it. That's why the APMs are a one-shot thing. They see that spike and take it. So that's why we always recommend them, because they are similarly designed in their intended effect on the system. So the alternator, it doesn't just pop for no reason, but it as a last ditch effort will take the brunt and destroy itself.
Yeah, gotcha. Okay, well, yeah, good stuff. And if we didn't get a chance to answer your question, we will capture those from the chat. We'll include this Q&A and answers to any outstanding questions in our blog post that'll come out in about a week or so. For those who stuck around, we just dropped a code in the chat, and that will be good for the next week. So we really appreciate you all being here, and hopefully that will be of some use for you. Last thing, as I mentioned, we'll be sharing our secondary alternator tech guide and our SOP documents with all professionals in our network. So if you're already have an account with us, then you'll be receiving that in a newsletter. Otherwise, you can join using the QR code on the left. And if you don't want to scan the code, we'll drop a link in the chat for that. We still have a few seats left for our Victron hands-on training happening at the end of April. So that's the QR code on the right. We'll drop a link for that, and you can learn more about that one and future training opportunities. Before you go, please drop a note in the chat with what you'd like to learn about next time, what our next webinar should be about. We really appreciate you guys being here. Thanks, everybody.